Yeah, good morning, everyone. So, in previous class, we learned what changes are there in data types like array and object. So, in TypeScript, data types, the primitive types, and the non-primitive we learned. So, we discussed about how do we deal with arrays. Last session, we learned about array and object. So, what is difference in declaring arrays and declaring an object? What is the new concept of object you learned here is here objects are schema based, structured. You can define a structure for the object and two additional points you learned here, that is they can have optional properties. We generally call them as nullable. They can have nullable properties. Nullable properties are defined by using question mark, right? And usually we can have read-only properties. So read-only properties will not allow to assign values after initialization. These are some new points you learned about object. Now, the another point is how you define array of objects. We learnt array and we learnt object. So now how you declare an array of objects? How you declare an array of objects? For example, we want some array of objects. So syntactically, the array of objects, how you declare, generally we have JSON type data. We will have an array of objects. So how do you declare array of objects is we have some data. This data must be an array of objects. So we configure as an object type array. That is how we declare. That is object type array. That's how we configure an array of objects. So we need to define. That means this data is having an object, but it is a collection of objects, array type of objects. That means more than one, multiple. So usually how you define this? So let some data, the object must have a name and the object must have a price. So, and it is not one, it is an array. That means it is multiple. Now you can store array of objects. Every object should have a name and every object must have a price. We can define in this way. And we can add multiple objects like this. We can define multiple objects like that and store them. So this is how you declare an array for handling collection of objects. Object type array. That's how we define. So array and object type array. So let's see here, suppose we are creating data. Data is, suppose we say products. Products is what? Products is an object with a name, string, and a price number, and it is an array type, so that you can have an array, and this array have objects. Every object must have a name, and it must have a price. It must have a price. So name and so must have a price, right? This is how we configure the data. So dealing with data, how to manipulate? Manipulation is same. There is no change in the manipulation. How you manipulate, that means how you read, how you present, those methods are same. There is no change. How you define, so we have a for, or we can use products dot map, so we can read every product, and for every product we can print the details, console.log, and we are printing here like product dot name, and we have product dot price and a slash n. We are just printing the products in every line. So dealing with collections is same, only the declaration changes you need to find out here. So CDSRC, TSC, products, sorry, index.ts, and you have node index.js, and it is what it is showing all the details. So configuring and accessing will be same. So this is the example of that. How you define array, object, and an array of objects, how to deal with them. Next, important is how you define a map type. So map type. Already you know what is difference between object and map. Object and map difference is object keys are string, but map keys can be any type. Object keys are string only. All keys must be string. But in map, keys must be can be any type. Another point is in a map, there are all map provides all implicit methods. For manipulation, all methods are implicitly available. So map is faster than object. So map is lightweight in operation, but it is not structured. Object requires all explicit methods for deleting a property, for finding a property. It needs explicit methods. That is why it is slow. But what is advantage is it is structured. What you learn in JavaScript about map is the map keys can be any type, and object keys are string type. But here you can change that. That means you can design a map in TypeScript in such a way that its keys also can be same type. All number type keys or string type keys you can define, which is not possible in JavaScript. So actually to learn this, I told you to learn this map type, you need to learn a topic called generics. Later you will learn, but just a definition I will show here. Actually, in JavaScript map type can have various types of keys, can have various types of keys. So, and the important is it provides implicit methods to handle operations faster than object, to handle operations faster than object type. So what is new in TypeScript is TypeScript can restrict the data type for keys. TypeScript can restrict the data type for keys. So other operations, other operations are same. Only one additional thing is it can restrict the data type for keys. In JavaScript, we cannot restrict the data type for keys. In JavaScript, map can be any type. The keys can be any type. Here, we can define specific type. We need a generic actually. So map is generic type. What is generic? In the next concept, we will learn about that. So later you will learn about generic. In OOPS, we will see that. Here, how you declare a map, how to handle it. For example, we are declaring LET, some data is equal to, so it is a map type. That means new map type. We define like a map. Actually now, this data is a map type. But this angle bracket indicates it's a generic type. Later I will tell you about generics as I told you. Actual point is, what is this map type is, currently key can be any type, value can be any type. It can have any type key, any type value. But you can restrict if you want. So generic types are defined with an angle bracket. There you have to mention what should be the key type and what should be the value type. Key type, I want a number, and value, I want a string. Like this, you can configure. Earlier in JavaScript, keys, values, you can't restrict. Key can be any type, value can be any type. That means in one document, key is a number, value is an array. In another document, key is a string, value is a number. It can have anything. But now it is restricted. Now all keys must be what type? Number type. And all values must be string type. We can restrict the type. Of course, if you want value can be any, then you can use any type. That means keys must be number, values can be any type. We can put the restrictions like that. Now you cannot store any other type if you are defining. For example, you see now if I do like this, and how to delay map, you know already. To mention the data type, here we have to mention the data type. What is the data type? Data type as what? Map. And what is its data types? Key type. Key type is a number and value type is a string. And in that case, you don't mention here. That means now the memory allocated for the map So it is overloading with these types. Now this is the map type and the key and values are configured. Now when you are defining here, you see now data dot set, and in that key must be number, value must be string. It is restricted now. You store something A and you store something like some number, it is not allowed because it must be a number type and a string type. You know the map related methods: get, set, remove, clear, delete. All these kind of methods are available. You can implement. You know how to read also values, keys, or entries. These are all the methods of map. So there is no change in the map type manipulation, but storing data is generic. That means syntactically how you define. We have data. Data is a map type. In that, you must be mention the key type. You must mention the key type and the value type. Actually, say key type and value type. And the new map memory is allocated. That means you can configure LET data. It is a map, and in this, you can have a number and you can have a string. You can configure like this, or you can define like map a string and any type. That means key must be string and the value can be any type. Now, how to manipulate? All the operations are same. That means what operations you have: data dot set, data dot get, data dot delete, data dot clear. So data dot has to verify whether key is present or not. So data dot values, it will read all the values. Data dot keys, it will read all the keys. Data dot entries, it will read all the keys and values. Right? So these are all the manipulations we are having. We have data dot size. How many keys are present? So map is not a new concept for JavaScript people. In TypeScript, what changes are there? That is the key point. Generally in JavaScript, map have key any type, value any type. So, and map is considered as fastest one when compared to object. But map is considered as structureless data because key value can be any type. But now we don't have that problem. We have a proper structured data. Suppose how you will define map in such a way that here, suppose how you will define map in such a way that key must be number and value must be array. Then you can put a string array. That means now key must be number, value must be a string array. You can put any complex thing. And if you want any type of array, then you use any array. Suppose key must be string, value must be object. You can put an object here. And what is that object structure? You have to mention the structure. It must have name, which is a string. It must have price. It must be a number. Like this, you can define. Then how do we set the data? Data dot set. The key must be number and value must be an object. This object must have a name and it should have a price. That is how we define the complex data. How we can access the keys console.log data.get number one, and it will read that object. That is how we can access anything, right? So usually now when I compile and run this, sorry, so transcompile and run this, yeah. So you can see, so we will run. There is no problem actually. It will display. Means it is showing a warning that you don't map like this. That means generic types. We haven't learned generic types. Later I will tell you. It is saying that this is not a correct definition of generic. It's fine. Later you will see that. But still it works. You see, it gets your data and show you. That means in that reference, what is present, it is going to access and display. So usually map can have any kind of data. Just a rough example I will give here. This is just an example to understand how you configure a map. Configure the map. Usually, what is difference between object and map is one of the question regularly comes. What is difference between object and map? It's a one common question we have seen in React interviews. As I already told you, React interviews 60-70% of questions will be all JavaScript only. And this is one regular question we see in React interviews. And you know the difference. You know the difference. I'm not giving the answer here. Already you know in JavaScript, just I given the question. So these are key points. And this is one new thing you should know about map type. Next, another important in the data types is date type. Date type. How you configure a date and time value. Generally, in JavaScript, what you do to store a date and time value, you will use a date constructor. Date constructor. Here, you have to use that as a type. So, date methods and the manipulations are same as in JavaScript. So date. Here, configuring date requires date type. Configuring date requires date type. So syntactically, some departure. So it is a date and new date. And you know what this will do? It loads current date and time. How you load specific date and time? Departure date is equal to new date. Here, you know, year, month, day, hours, minutes, second, and milliseconds. You know, this is the order, right? To store any specific date, you know the order of date, how to store the date. So year, month, day, hours, minutes, seconds, and milliseconds. This is not React we are discussing. It is TypeScript. When it comes to React, in React also we declare same, but while reading in React, we use adapters like day.js and adapter like Memento. So configuring date and reading date directly in TypeScript is same. All date methods are same. Get hours, get minutes, get seconds, set hours, set minutes, set seconds, all are same. So only the configuration is important. For example, you want to deal with some date. So MFD, manufactured, is a date, is equal to new date. And here we have 2024, 01, and some 21. So, and 16, 35, and 22, like this we define. Hmm. Now we want to access this. Then how do you define that? So we just use console log, and you know how to access it. So we need to define manufactured, and here we have to use mfd dot to date string. We can just access that and show. Just for your understanding sake, actually, I am using a command prompt. You can directly run in terminal just to show in a clear screen. Yeah. So here tsc index.ts and node index.js. And this is the manufactured. It will show that here. So to string, that means it is going to display both date and time. To date string, to time string, it is going to display both date and time. You know how to present the dates by using the format. Only the way of declaration will be changing. Configuring the date will be changing. Rest of options are same. This is an example. And what about another is regular expression type. Regular expression type. Actually, in JavaScript, directly you store a regular expression in a variable. And you know that regular expression must be enclosed in 2/. But here we have a separate data type for that. That means TypeScript. TypeScript can handle regular expression by using regexp type. It can use this type. So, and what a regular expression contains? So, expression is defined within // right? And expression, it is a set of what? Meta characters and quantifiers. You know that it is a set of meta characters and quantifiers. For regular expression, we have a separate data type here. And you know that expression is verified by using match method. You know that it is verified by using the match method. All other points are same. How you write expression is declaration is different. Different means in the sense here you have to mention data type. You have to define the data type. So it can handle regular expression by using this. So now how you configure this, how do you declare this is like let, and now we have a data type. So for example, we are using an pattern. Pattern is what type? Regular expression type. Then how you define a regular expression? In slash, two slashes you have to configure. Suppose I am writing a regular expression slash plus 91 slash d 10 digit number like this. And what is your mobile? So mobile is a string, and the string regular expression verification must be with a string type. And string is like 987654321 like this. How to verify that? If mobile is matching with pattern. If it is matching with pattern, so log, so verified. Otherwise, we should put a log and say invalid. That is invalid mobile something. That's a general thing. Already we know how to handle it. Just only the declaration have a data type. So when you are dealing with the type in console, you don't have alerts, prompts, or you cannot have like any input like options. You have to statically configure the input. Otherwise, you put it in a HTML where you can have prompt or form from where you can input and you can use it. So initially here, compile this and run this, and you can see it is invalid mobile because it must start with +91. Then we will compile this and run this. It is verifying the pattern correctly. So how do we write a regular expression and how to validate? That is the syntax here. So pattern, it uses a regular expression, and here you write the pattern. That is how we configure. So example, I will copy this one. This is just an example for the regular expression type. So these are all different data types that you generally handle in your JavaScript based application. So JavaScript based applications, primitive types, non-primitive types, and all the other additional data types that you have to manage, right? Next, after understanding about what is new in the data types and variables of TypeScript. Now, second one in the language is about statements, because all this I explained under variables, variables, data types, the concept, and statements. First one is variable, second data type. So, and here we have statements are same, statements are same, operators are same. So there is no change in them. All statements means, statements, selection statements, jump statements, looping iteration statements, exception handling statements, all are same, no change. Operators all are same, there is no change. So JavaScript, all operators are same here. Now, the next one is functions. Functions are different now. So we have functions. So let's say TypeScript. In TypeScript functions, what is the change? TypeScript functions, what is new in function? already we know what is the purpose of a function. In JavaScript, we learned about that. Functions are used for technically functions are used for refactoring the code. The technical term is refactor the code. In JavaScript, functions are used for refactoring. Refactoring is the process of extracting a set of lines and enclosing in a function so that you can reuse. That mechanism is called refactor. In JavaScript, you already learned that term. Actually, suppose you are writing some condition for where I is equal to 1, I less than or equal to 10, I plus plus, and you have like console.log I. Now I want these statements to use again and again. Then you can select these statements, you can right click on them, and you can refactor. You have a mechanism called refactor. When you select refactor, it will ask extract to function. And what is the function name? Print numbers. It automatically creates a function. The process of extracting a set of lines and configuring in a function in order to reuse. This is called refactoring. Creating a function and storing some functionality inside it is refactoring. Technically, we call it as refactor. That's generally in JavaScript also same thing will be there, right? So actually functions are used to refactor the code, are used to refactor the code so that you can reuse the code. Refactoring is the process of extracting a set of statements into a function. Extracting a set of statements into a function. That is the mechanism of refactor. Extracting a set of statements into function. That is general JavaScript definition also, right? In JavaScript, that is how you learned about a function. Here, same point, but what is new here is in a TypeScript, TypeScript function, TypeScript function configuration, function configuration comprises of data type specification, data type specification. TypeScript function configuration comprises of data type specification. Extra is this, rest of points are same. Data type specification for whom? For parameters, for complete functionals. That means, what is that means is syntactically, we have a function, function name, and parameter, its type, and the complete function type also you define. If it is not returning any type, then it should be what type? Void. You have to configure in this way. That means what is new in the function declaration is the parameters that you write in a function, they must be defined with data type. And the return type you have to define. If it is not returning any value, then you configure it as what? Void. That's how we do. So that means how do you write a function? Suppose example, like suppose we have a function addition. We have A number type and B number type. That is how we declare the, and the data type is number type. What does it means? It means that it should return A plus B. If you try to return A greater than B, it is invalid. Why invalid? Because the function return type is number and you are returning a boolean. A greater than B is a boolean, na? Right? So what is the return type you said? The return type should be number. That means the final return must be a number. It is not a number, it is a boolean. So that means it is not valid. If you mention any, then it is okay. Right? So if you define a boolean, then it is okay. But if you define a number, that means it should return a number. It should return a number. For example, you are defining a function, so print, and it is not doing anything. It is just printing a message, console.log hello, something like this. Now, what is its type? It is an void type. It is an void type. If your intention is to return something and store that in the function memory, then its data type must be defined. And if your intention not to store any return value returned by the function, then make it as what? Void. And if there are parameters, the parameters must be defined with a type. And all other features are same. There is no change. What all other features? Function closures, function rest parameters, spread operators, arrow functions, and callbacks, promises, everything same, no change. Only the point is declaration with the data types. All other function related concepts will not change. They will be same. So wherever you mention data type, you define the, wherever you mention the parameter and the return, you have to mention the data type. That is only the new. Rest of all concepts are same. For example, how you define a function in JavaScript and how you define here. So we have a function and function name is addition and it will have A and B, and you can see that it is not satisfied with the parameters. Why? Because you need to mention the data type for them. It is a number and this is also a number. And if you are trying to return, if you're not returning anything, then by default it is void type. But if you are returning, A plus B, then this becomes a number type. If you are returning A greater than B, then it becomes an Boolean type. Boolean type. But if you don't want this expression to change, then you can fix it to what type? To number type. Then it cannot return A greater than B. It should always A plus B. That's how we configure the function. Suppose we are having a function and the function have a print, and the print is an void type, and in that console.log we are printing addition is equal to, we access addition function, into that we pass the numbers. That's how we do. And you know that parameter can be any type. That means you can have array type parameter, object type parameter, multiple parameters. You can have rest type parameters. You already know less rest parameters, spread syntax and all. All other concepts are same. Suppose I am accessing print function and you can see it is same. I will compile and run this. The print function is same. There is no change. Now the point is how you define the data types means, for example, see, suppose we have a function and details, and this function is expecting dot 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 product. Like this, it is expecting. What does that means? It is a REST parameter. Now tell me, what is the REST parameter data type? REST parameter is collection of multiple values, na? Then what is its data type? Array. What is new in that? What is the REST parameter data type? Type of REST parameter is always array. That means why it is showing error here? It is showing error because you haven't mentioned the type. And what is its type? It is an array type. That means you configure it as what type? Array type. So that means an any type array. Because if you are expecting different type of values, then this. If you are expecting only string values, then string array. Previously, REST parameters can handle any type. Now REST parameters you can restrict. You can make the REST parameters all arguments string type, all arguments number type, or arguments can be any type. So REST parameter is same. Only the point is its data type can be changed. You can make the REST parameters as what type? String type. That means into this, we have to pass what we have to pass. Whenever we access details, into that we have to pass only string type. We need to pass a string type now. That means multiple arguments. How do you pass? Suppose A, so B like this. Suppose you pass a 10, it's not allowed because its type is string. And you need to pass only these types. That is allowed. And how, what is the final data type? Final data type is what? Void. How you configure it. When you are dealing with REST parameters, this is one new concept is you can restrict your REST parameter argument types. Generally, REST parameter can have any type of arguments. We can restrict the argument type to string or number, or you can make it any type. That is one advantage here is. So what is another point you need to know is, so REST parameters in function can be configured, can be restricted with the specific type of arguments, with a specific type of arguments. Syntactically, you have a function and the function name dot 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 params, and it is any type array. This is nothing but any type. Or you have a function, the name, and params, it is a string type array. That means only string arguments are allowed. Means just above, I will give a point. In the name, you can pass 10 a true like this. But here in the name, you can pass only 10, only A or B or C. Other types are not allowed. That depends on how you configure the type. And just keep this void to make it standard like. So the function parameters. So here other function related concepts. So no need to discuss. You already know closures, callbacks, promises, everything will be similar. So that no need to learn. We will, however, use them in our React. We will use them in the React option. That's interesting actually now. For example, suppose in React, you are creating a component. You are creating a component. Just roughly, I'm saying, later you will see that. Actually, component is a function. That means how do you write export function login is a component. Now tell me what should be data type. What should be the data type of what it should read. Actually, what you do, you return, you return a markup like this. Am I right? So now can you tell what is its data type? What is this type? What is its type? So what is the login type? Actually, it is an JSX element type because that markup is a JSX element. No? Every React component returns what? JSX element. Then obviously it should be JSX element. That is not required for you in JavaScript based React. But when you use TypeScript, these things will come now. That means you have to mention the data type. However, what is advantage for us is even you don't mention the data type, according to what you written, it will fix the data type. But that is not the case in every project because in some project such rules are disabled. Then you have to manually mention the type. Mention the type. That means first you should know what is its type. Usually it is a JSX element type, right? So later in React, you will see just I'm explaining that how these are important. That means why these data type points are important. It cannot be void. Obviously, it is returning, so it is not void. So it should return. It is returning a markup. Markup means it is an JSX element. For example, do you know here means you have seen where root is equal to, you remembered you have React have a create root method now. Create root method. This is accessing document dot get element by ID, get element by ID. So some root that is actually referring to some div. Now tell me what is data type of this root. Document get element by ID is not a JSX1. Na? It is not virtual DOM. It is actual DOM. What is the data type of root? So it is an HTML element type. HTML element type. Actually, we don't write like this. We define as HTML element type. Like this we define. That means it is used as HTML element type. That is some changes you will see. Remember, what whatever React you learned with JavaScript, exactly same. There is no change, only data types. Everywhere, data type is only the concern. Rest of concepts will never change. That means you can build a complete project in TypeScript only just by assigning data types to every reference. In JavaScript, whatever references you created, those references you use here same, but additionally you mention the types, data types. That's what you need to do, right? So this is related to function. When you are dealing with functions, these are important. So what is new about functions in TypeScript is just parameter type and return type. Parameter type and return type. That is only the key thing. Rest of all concept is same, right? That is all about functions. What changes are there in the functions, right? Now in a TypeScript, the major part of TypeScript is the TypeScript object-oriented programming. Here, lot of changes are there. TypeScript object-oriented programming. Because JavaScript is not a perfect object-oriented programming, several concepts are not available. But TypeScript is good object-oriented programming language. So it supports certain all programming of OOP features. So typically in object-oriented programming, there are so many concepts. Actually, one confusion I have to reduce here. The point is, if I ask what are the features of OOPs, what are the features of OOPs, then usually from learner level, we will hear inheritance, polymorphism, abstraction, encapsulation. They are not features of OOPs. They are not features of OOPs. They are the characteristics of OOPs. We call them OOP characteristics. What is polymorphism, inheritance, abstraction, encapsulation? These are characteristics, OOP characteristics. Then what are features? Features means reusability, separation, security. All this comes under features. Because of these characteristics, those features will come. What is the characteristic feature? Inheritance feature is what? Inheritance is a characteristics. Because of that characteristic, what feature will come? Reusability and extensibility. Code reusability and extensibility can be achieved by using the characteristic called inheritance. Inheritance is not a feature. Inheritance is a characteristics. Through that, these features will come. So that's one basic thing you should know. OOP characteristics and OOP features. So actually, features, reusability, separation, extensibility, code security, all this comes under the features. Reusability, separation, extensibility, security, all these are the features. Characteristics, characteristics, right? So what is the spell? Characteristics. What is the characteristics? What are the characteristics? Characteristics we have like inheritance, polymorphism, abstraction, encapsulation. These are the characteristics. Means just I'm giving some. These are the characteristics like concept. So OOP have certain features. These features are because of these characteristics, right? And what is the new thing you will learn here in the OOP concepts? The first important is in the object oriented programming, we learn about contracts in OOP. Contracts in OOP means that is the technical term we use actually. Contracts in OOP. Contract means in object oriented programming languages, whenever you are designing a component, for every design, there are certain rules to follow. What is the key fact about OOP is behind every design, there will be a contract. That means contracts define rules for designing a component. That means you cannot design a component just like that. You have to follow certain rules. We have to follow the rules. Actually, uh, technical speaking here, the technical word is contract. What is general word? I will tell you, right? What is a contract? A contract defines rules for designing a component. Contract defines rules for designing a component. So it defines rules. We cannot design. What is advantage of contract is you can reuse the contract for various components. That is the key point here. We can reuse the contract for various components. And component must be designed according to contract. Component must be designed according to contract. So what is in the contract? Only that you have to do. That means if developer tries to violate the contract, then it will fail. It will warn him. It will show errors. So we can force developers to design with certain rules by using these contracts. Actually, for example, in our previous concept, we already learned, see, suppose we have a product. Actually, this product have a name and it have price, something like this. Now, generally, as of now, we can store anything inside. Price can be string. You can store anything. It doesn't matter. Now, how you mention rules for this? How you mention the rules for designing a product? We already learned. We put a schema. How you put the schema colon? What is the contract? That means you should mention the rules here. What are the rules? Name must be what type? String. Price must be what type? Number. And it must have a stock, which is what type? Boolean. That means this is a contract. This is a contract for designing this component. According to that contract only you have to design. But this is not reusable. Suppose another product have to use the same contract. Another place we want to use the same rules. Then how you will reuse it? That is what programming people call it as interface. That's what programming calls as interface. That means we create an interface, means we are creating a contract. And what is that interface? It is an product contract. Suppose I given a product contract. According to the contract, it should have a name and it should have a price and it should have a stock, and which is what type? Boolean. And now the product will use that product contract. That's how we design. Now the contracts are reusable. Interfaces are called contracts. If in interviews, if anybody asks like what is an interface, you may tell several stories about it. Technically, they are not satisfied. In real world architectural point of view, a interface means contract. That means why we use interfaces? Simple, to design contracts, nothing else. A contract is designed in OOP languages by using interface. Interface. That means that is interface contains set of rules that define how a component need to be designed. So that means by using interfaces, you can design a contract. Interface is contract. And now you have to do according to that. That means price must be what type number. And it is error because it is missing with what? Stock. That means now what we have to do, we have to mention stock as true, false. This time, these set of rules are reusable. You can apply to any component and you can implement for any component. So in object-oriented programming, so contracts are designed. Contracts are designed by using interface. So that means interface means contract. So it is defined by using interface. Designed by using interface. Syntactically, so here we have an interface and interface name. I name. Just given an I name. And here you define the rules. And interface can contain only rules. It cannot contain any implementation of rules. Interface can contain only rules. Only rules. That means you cannot say, so name string is equal to some empty. That means you cannot assign any values. It contains only rule. That means only rules. It contains only rules. What should be the key and what should be its type? It can contain only rules. So example here, interface, we have a I product and we have name as a string and the price as a number. And how you configured this? So LET product, it should use this I product contract. Then it must be designed accordingly. Name and price we need to define accordingly. That's how we configure. So that is interface. So if anyone asks like what is the purpose of an interface in OOP language, at architectural point of view, we say for designing contracts. And what a contract have? Rules for designing a component. That means you will mention what are the rules a component have to follow. So, and there are some points which we already know. These can be rules can be can be for a property or a method. Rules can be for a property or a method. You can have rules for a property or a method. Later you will use in classes. Currently we are using for object. Currently we are designing a contract and using for an object. Later we will implement for a class. Later we will see for classes how classes will use these contracts. That means, component means it can be designed with a function or it can be designed by using class. That contract can be implemented by both, right? So it can be for both property and method. What does it means? Suppose you mentioned this quantity and we have a quantity. It is what type? Number. And what we need here is, so total. Total is a method. It should be what type? Number. Print is a method. It should be what type? Void. These are the rules. Then according to the rules, you have to design the product contract. So name and price are fine. Quantity is 2. What about total? Total must be a function. And what this function have to do? It cannot be void. It should return this dot quantity into what? This dot price. Still it is not satisfied because print is not implemented. How you can make it optional? So you can add question mark. You can have optional. Right? Otherwise, everything you mentioned must be implemented here. That means, again, we have another option. What is it? Print. Print is a function, and this function should print all the details. Like we have name, this dot name, we have price. So that is this dot price. We have quantity and this dot quantity and total and this dot total. We have to configure this. We have to configure. Now that is how we manage. Now what we will do here, we will define a simple technique, that is product dot what method? Print. Print. Rest of options are same. Here this time we have certain rules to follow and we are configuring the rules for designing a component. That's what we are doing. Right? This is the concept of how we define the rules and use the rules. This is example for that. But still about interface, some more points are there. Optional rules, read-only rules, extending contracts, how we can extend contracts. There are so many points that we'll see tomorrow. So in tomorrow's session, we will discuss about more about interface, classes. Some changes are there now. Lot of new things you will see in the concept of OOP, right? Tomorrow we will continue with that. Okay, right. And if any old 7 a.m. UI people are there, so because in this batch our 7 a.m. UI people are continuing, so the concepts of SAS and jQuery, these topics are starting 9 a.m. batch. In the 9 a.m. batch, you can continue. So after 7 a.m., 9 a.m., not for React, only React people. We have a previous UI full stack people continuing in this batch, 7 a.m. people. 9 a.m., you will have a SAS and jQuery you can attend. So otherwise, later in any another batch it starts, you can attend there also. Currently from today onwards, 9 a.m., that batch is starting. For online people, I will post a link. For offline people in the same classroom, it will happen. Okay, right. So general React people tomorrow will continue with that. Okay, right.